Hi guys. So since I wasn't gonna be there today, the last time we were there, you had to do 3 assignments, and this is one of them. This was the individual assignment. So I don't know if you've done it so far. So if you haven't done it, take it out. What you're gonna do, it's called Life on the Edge. What you're gonna do is flip it around, and then you're gonna see this periodic table. And one thing that you're gonna have to take into account is a little bit of notes, real quick. Okay, I think the last time we were there, we said in order to determine how many electrons fit in shell N, we said we were going to do 2n squared, and that should give you the max number of electrons that fit in shell N. And so you'll start noticing that for n equals 1, you can fit 2 electrons. For n equals 2, you can fit 8 electrons. And what you're doing is you're plugging in that 2 into the n spot, and you're pretty much just doing real quick math. 18 electrons, and n equals 4, 32 electrons, okay? Now this is a maximum number that you can fit. That doesn't necessarily mean that you can't fit any less than that. And then 2 things that you need to realize is that over here, you'll have something called as a period, yeah? Which are the rows. So that's period 1, period 2, and then down here we have period 3 and period 4. Okay, so these are known as periods, also known as shells. Okay, now in period 1, if you notice, there's only one ring or shell. I should also put rings here, huh? If you notice in row 2, all of them have 2 rings, 1, 2. And then if you notice that in period 3, you have 3 rings, 1, 2, and 3, and then period 4, 1, 2, 3, and 4. Okay? And then the last thing are the groups. Remember that, oh, I forgot to put right here that they're also rows. Okay? So groups, those are columns. So groups are columns. They're also families. And one thing that you have to remember is that here, they're going to have the same number of valence electrons. And now remember, you also have to define what is a valence electron. A valence electron is the electrons that are in the outer shell. Excuse me. And all the other ones are called core electrons. And I'm just saying core electrons are all other electrons closer to the nucleus. Okay, so real quick, I'm going to show you how to do beryllium. And remember, this is a video, so you can pause it and make it go as you wish. So we're going to do real quick beryllium. And one thing that you notice about hydrogen, look, it has a nucleus, but we're not worried about the nucleus. We're just looking at the electrons. Here you notice that there's one electron in the outer shell, and the only shell for hydrogen. Okay, and then if you look as you go down the group, there's one electron in the outer shell, one electron in the outer shell for sodium, and one electron in the outer shell for potassium. Now, if you go across, you're adding electrons. Look at here. We started off with one. We went over to helium, and now all of a sudden we have two. Yeah. So for lithium, you have 3 electrons. Now, why? All of these atoms are neutral, so therefore the atomic number is also going to give you the number of electrons. If you notice here, you have 3 electrons. How are you going to fill them in? Well, remember that we have to go back to our shells. How many fit in the first shell? Well, then, at max 2. So then you start off with the first ring and you're going to put in 2 electrons. And then you're only left over with 1 electron, so that's the electron that's going to go in the second shell. I'm going to show you real quick how to do beryllium, but I'm going to do it in colors. Hopefully you can see the colors. Here we're going to start off with a red marker to signify the nucleus. And now remember, beryllium is in what row? It's in row 2, so it's in period 2. And so therefore this tells us that it has 2 shells. Now remember that shells are the rings. Now, if you look at the periodic table, the atomic number for beryllium is 4. So that tells us that it has 4 electrons. So how are we going to fill those 4 electrons in? Well, very quick. We go back to our shell. Shell 1 can fit 2 electrons, so you're going to start off with the inside shell. 1 and 2. Next, you're going to go on to shell 2. Shell 2 can fit up to 8 electrons, but you only have 2 left. Because the total number of electrons for beryllium is 4, you only have 2 left, so therefore you can just put them right there. Or some people like to put them opposite side, right there. And that's pretty much it. If you notice, look, it has 2 rings like all the other ones in row 2. The only difference is that, look, at this one has 3 electrons total, while this one has 4 electrons. And then if you go on to boron, boron has 5 electrons. How did they fit those in? Well, they put 2 in the first shell and then 3 in the outer shell. Yeah. If you notice, next one, we have carbon. Okay. Carbon, again, it's because it's in period 2. It has how many rings? 2. Okay, remember the red is a nucleus, so we don't really worry about the nucleus right now. Okay. 2 rings for carbon. And now we have to find the atomic number for carbon. The atomic number for carbon is 6. So how many electrons are we going to have? 6. So now, again, we start off shell 1. Shell 1, we have to put in at least 2 electrons at max 2. So there's where you start. 2 electrons. Next, you're going to add, if you subtract 6 minus the 2 that you added, you have 4 left. So we're going to put those 4 right there. 2, 3, and 4. Okay. Now again, if you're looking at nitrogen, we're adding another one. Nitrogen has 7 electrons. If you notice, we're just adding 1 and we're adding it to the outer shell. 8 electrons. Again, we're adding it to the outer shell. I'm sorry, fluorine has 9 electrons. Okay, let's put this in here so it's not confusing to which one I'm going to tell you later. Okay, oops. That's 7. Okay, and then if you look at neon, it has 10 electrons. If you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.